Today, we're gonna look at type 2 of transformations. Remember yesterday, we looked at translation, which was a slide left and right. So now we're gonna look at these other types that are gonna be, include reflections. And we're also gonna include what last year y'all would have called dilations. I don't really use that word. We're gonna use a shrink and a stretch, and we'll talk about that as we go along. Alright, so linear parent function, f of x. Tell me what you know about f of x. Slope of 1, y-intercept at 0. Never changes. Alright. Can be transformed by multiplying. And it's always multiplication. Alright, by multiplying the function or its input values by a given value. Alright, so it says observe how multiplying the function by 2 will affect the graph of f of x by completing the table on the left and creating the graph over here. So I'm going to use kind of some color to do that just so we can see the different ones. Alright, so if I take this right here, here's my function f of x, which is just x, and I multiply it times 2. So if you notice right here, this 2 out here is on the outside. It matters where it's located. Just like on the translations, it matters where it's located. So if I multiply 2 times 0 with the y-intercept, 2 times 0 is going to be, my x value is 0, then 2 times 0 is 0. Alright, if my x value is 1, 2 times 1 is 2. If my x value is 2, 2 times 2 is 4. And if my x value is 3, 2 times 3 is 6. And I'm only going to graph like the top side of this graph. So, and this is going to be my g of x, so I'm still at 0, 0, I'm at 1 and 2, I'm at 2 and 4, and I'm at 3 and 6. Where would I be at 4?
8.
And 8 up here, okay? So, there is g of x, and again, I only did the top part of it, I'm not doing the whole graph. Alright, that gives us enough to be able to see what we've got, okay? So then, we're going to look at what happens if I have, now this time they have a half and it's on the inside. So make note that it is on the inside. Okay, so if my x value is 0, when I do 1/2 times x, I'm still going to get what? 0. If I make my x value 2, why do you think they chose 2? What are we multiplying by? A half. Well, if I multiply a half by 1, I'm going to get what? A half. We don't want to graph halves. So they chose 2 so that I would end up with 2 times a half is what? 1. Then they chose 4, which is going to give me what? 2. Then they chose 6, which is going to give me 3. Okay. So when I plug this in here and I go get ready to graph that, I've got 0, 0 still. I've got 2 and 1, I've got 4 and 2, and I've got 6 and 3, and if I had gone to 8, I would get 8 and 4. Alright, so that one is going to be called h of x. Alright, we okay there? Alright, so they want me to find the y-intercept of each function. So f of x, what's the y-intercept? 0. G of x, what's the y-intercept? Also 0. And h of x, also 0. So, what is unchanged when I multiply my function? The y-intercept is unchanged, which is different than when we did a slide, right? When we had a translation, our y-intercept absolutely changed every single time. It didn't matter whether I went up or down or left or right, my y-intercept was still affected. But when I do multiplication, my y-intercept is not affected. It acts like a hinge. Are y'all okay with what I mean by a hinge? Okay. Alright, so it wants me to find the slope. So what is the slope of f of x, my parent? 1. What is the slope of g of x? 2, and the slope of h of x is 1/2. So when I multiply my function, it changes my slope by whatever I multiplied by. Are we okay with that? Everybody comfortable there? Alright, so it says summarize the effects. We really just said that. So what happens to the y-intercept? slope, what? Works for me, changes by, the factor you multiply by, that works for me. Okay, so let's talk for just a second. If I multiply it by 2, let's talk g of x here. If I multiply by 2, how would you describe visually the line in comparison to f for 2? How could you say it's different?
It's steeper.
Steeper, good, that's the word I was looking for. So if my slope or my number that I multiplied by is greater than 1, it's gonna be steeper. And if I multiply it by less than 1, what's gonna happen? It's gonna be what? Flatter. That's usually what I use for linears. Steeper or flatter. Everybody okay with that? Okay. Alright, so transforming by a f of x and f b of x. So obviously, it's gonna be different when we look at different things. Alright, so, we can use a factor of a, which would be on the outside, and b on the inside. So yesterday, we used d on the outside and c on the inside. It's just so that they were, I really don't know why we used it, but that's just the way they set it up. Alright, so if a is greater than 1, it is going to be steeper, we already wrote that. If b is less than 1, then we are going to be flatter. They give you 2 blanks there to say less steep. I'm okay with flatter. If you prefer less steep, I'm fine if you write that. Everybody okay? Alright, so if we look at this right here, we are going to look at, so yesterday, we wrote VT and HT, and I gave you those abbreviations. We're going to look at those. I'm going to give you some different abbreviations today. Alright, so this one right here, we notice this 3/4, it is on the outside. Are we okay there? Yes? Okay, so it is on the outside, so we're going to call this a vertical. Is it more than 1 or less than 1? Less than 1, so it's a shrink by 3/4. A lot of times, like if you saw that on a test, they would probably use the word compression. I like the word shrink, but they mean the same thing. And they may say by a factor of 3/4. I'm not gonna make you write all that out. Okay, and I will also let you write it like this: B shrink by 3/4. Like, it doesn't save you a whole lot, but it saves you a little bit. So I'm okay with that. Everybody good there? All right. How's it visually going to change my graph if it's less than 1? It's going to make it flatter. We okay? All right. This one right here, I have this 4x. It's on the inside. These are the ones that are going to be a little bit tricky. All right. If it's visually, if I look at that, I'm multiplying by more than 1. And will you get those calculators from them? If I'm multiplying by more than 1, what happens? It gets steeper. Alright, so visually, it's going to get steeper. Alright, but this is where it gets tricky when we're inside of a parentheses. So when we had addition and subtraction in the parentheses, we had the opposite direction of what we had, right? If we had subtraction, we actually went to the right. If we had addition, we actually went to the left, yes? Okay, so that was a sign because it was addition and subtraction. When we have multiplication, when I say the opposite of 4, when I'm saying multiplication, I need to take its reciprocal. Is everybody okay with that? It would be how I would get rid of it. Is everybody comfortable with that? Okay. So I would have to take my 4 and I would flip it over, which means I'm gonna have a 1/4. Are y'all alright with that? Alright. So the way, but because it's inside, it's horizontal. Is everybody okay that it's horizontal? Okay. So it would be a horizontal. And this number ended up being less than 1, right? So it's still gonna be called a shrink or compression by 1/4, in which case you could write that as an H shrink by 1/4. Is everybody okay with that? It's still visually going to be steeper because I'm still multiplying the 4 times the x. Is everybody okay with that? So it still does what the number tells you, but its name is the opposite, just like yesterday with the subtraction and the addition inside the parentheses, the name was the opposite. Is everybody okay? Alright. Go back here to that. Alright, if I look at f of x, and I'm looking at g of x here. F of x, we know that's the parent function. You know it has a slope of 1 and a y-intercept at 0. Okay. Visually, what's the relationship between f and g? What happened? Steeper, flatter? Tell me that. We got flatter. It's getting closer to the x-axis. It's getting flatter. Is everybody okay with that? Alright. So let's find, they want us to find the b value. The b value is what I multiplied by. Well, remember, if we looked on the other side, what we were multiplying by ended up being our slope, right? Yes? So my b value then here is going to be my slope. So what is that? B is 2/3. Everybody okay that b is 2/3? That makes y'all are comfortable counting the slope, right? Okay. So if b is 2/3 and I know it got flatter, then I could write this as a vertical shrink, or I could write it as a horizontal stretch. Is everybody okay that I could write it as either one? Are y'all comfortable with that? Okay. They didn't ask me to do that, they just asked me to find b, and we found it. Everybody good? So it could be an H
Stretch.
yes, thank you, sorry, H stretch or a V shrink. And we don't know which one it is, we don't have enough information just by looking at it. Everybody okay there? Okay, alright, so let's see, Stefan graphed f of x equals x and p of x equals a times f of x. So they did tell us, oh, you know what, this one can't be both because they told it it was b in the inside. Sorry, totally my fault there. So it was h only, not b. Sorry about that. Alright, a f of x below. So it's on the outside, which means it has to be what? Vertical. Alright, so let's find the slope of because they want us to find a. So find me the slope of p. What is that going to be? It's -2. Okay. So there are actually two transformations that took place here. Alright? So because my sign changed, which made it flip over. Is everybody okay with that? And it stretched by 2. It's on the outside. Are y'all okay there? 2 is more than 1. So it's a vertical stretch by 2. It's also what we would call an x-axis reflection. And I know it's x-axis because the A is on that outside value. It's not inside the parentheses where they're saying B would be. Are y'all okay with what I'm saying there? Alright. So we can have a y-axis reflection as well. This one is x-axis because it would be with the A out here because there's nothing else inside there with x. Everybody okay? Alright. The function f and h are shown on the grid. Circle the name of the student who correctly wrote the function represented by h. For each incorrect student, describe how their function would relate to the function f beneath their work. Okay. So here's f. We know all about it. Tell me what you know about h. This says a slope of -1, so slope equals -1. Alright, so if it has a slope of -1, did I shrink or stretch it all? What's the only thing that happened if the slope is -1? Okay, look at it, like, how would you say, what would you say, if you just told me what the relationship is between f and h just by looking at it, what would you tell me? Yeah, I'm kinda, yeah, it's not really the word I was looking for. What happened up here from f? How do I get from up here to down here? Yeah, it's a reflection, so how do you think I got from here to here? A reflection, they have the exact same slope, just the opposite side. It would have to be a reflection. Do y'all understand that it has to be a reflection? Okay, so I'm looking for something that would tell me that. What does this say happened here? What does this say? What type of function is this? Transformation. Give me all of it. Vertical what? Down one. Well, that's not what we have, is it? Alright. What does this have? What did I do to f of x? Yeah, multiply it by what? By -1. Is that what it would take to get here? That's absolutely what it would take to get here. Like, Daniels wrote the right thing. What does hers say? For the right one. Okay? Alright, y'all, if the slope is -1 and this slope is +1, it's a reflection. Like, that's what it is. They are absolutely, Julian, you said they're perpendicular. That is absolutely true. In order for that to be true, it had to be reflected. We okay? Alright. Eduardo will graph f of x equals x and g of x equals f of 5/3 x on the same grid. Which function will have a steeper line? F of x or this one? F of x is going to be steeper or g of x is going to be steeper? What's the slope of f of x going to be? 1. What's the slope of g of x going to be? 5/3. Who's going to be steeper? G of x will be steeper. We okay? G of x. And I'm going to, here's my explanation. 5/3 greater than 1. What would I call that transformation? I know they're not asking you that right there, but I need you to be able to recognize it. It's inside, so it's going to be what? Horizontal. It's going to, what happens when it's inside? It's got to be the opposite. So what's the opposite of 5/3? 3/5, which means it's not going to be a stretch. It's going to be a what? A shrink. The name is its opposite. We okay there? Okay. 7. Delilah will graph f of x equals x and v of x equals 2f of x minus 3. How many transformations took place there? 2 of them on the same grid. How will v of x relate to f of x? So, let's talk about the first one. The first thing that we see that happens is this 2. How would I write that? So the 2, how does it affect my graph? Okay, vertically or horizontally? Okay, v stretch by 2. Alright, what is this -3 doing? How does that affect the graph?
That's where you get that.
Okay, so how do I write that case? BT down 3. Everybody okay? Alright, next one. The function f of x equals x has been transformed as shown below by line C. Describe the transformation and write a function for c of x that shows how it relates to f of x. Alright, so let's first see what happened. Tell me the things that have happened that you can tell. Like, how did I get from here to here? That should be the first thing you notice.
What changed something?
Yeah, it had to be reflected. Like, there's no way around that. It had to be flipped or reflected. Which means I'm going to have a negative sign somewhere. Does everybody agree? Okay. So then I need to find what? What did I do up in number 3 and number 4? What did I need to then go find?
The slope.
Okay, so find the slope there. -4. Okay, good. The slope is -4. Alright. So is this graph steeper or flatter than F? How do we know it's steeper? Yeah, it's more than 1. Yes, it's negative, but we're not worried about the negative. The negative has to do with the direction. But it is absolutely steeper. Are we okay with that? Alright, what is the y-intercept of my new graph? 3. Okay. So I flipped, I stretched, and I slid up the graph. Does everybody agree that that's what we did? Okay. So let's think of how we can write that. So c of x is, and I've got to relate it to f of x. So how can we write that? There's more than one way, But here's my deal, verticals are way easier to write than horizontals, so if you have a choice, I would write a vertical. So, how do I capture this slope of -4 and a y-intercept change of 3? Where do I write things? Y'all gotta tell me.
-4 x and then up +3.
Perfect. -4 f of x plus 3. You're gonna have to be able to do that. You gotta take a look at what happened and then tie it back to your original equation and how it changed. Now here's the deal. Could I have written it another way? I could have, but I don't wanna write the horizontal if I don't have to, because then I have to switch everything and do all the opposite stuff. And we would rather not do that if we can avoid it. Does that make sense? Okay. Alright, so we're gonna kinda write some stuff down here in these boxes and we're gonna wrap it up. Alright, if I have a f of x, a is on the outside, so that automatically tells me that it's vertical. Everybody okay there? Alright, how will that affect my graph? It will either make it do one of two things. What is it gonna be? No. Yeah, steeper or flatter, which we're gonna call stretch or shrink. Like, that's what it's gonna do. Absolutely steeper or flatter, like how we can write that also. Steeper, flatter. If it's steeper, what kind of number would A have been? Greater than 1. If it was flatter, my number would have been less than 1. Are we okay there? What happens to the y-intercept if I just do a shrink or stretch? Stays the same. Everybody okay? That stays the same. Everybody good? Alright, if I have f of bx, then the multiplication is taking place inside. That's horizontal. Okay? So then that also gives me a stretch or a shrink. Are y'all okay? It still does that. It's just horizontal instead of vertical. All good? Alright. It also makes it steeper or flatter, right? Yes? In this case, my stretch is actually the one, or sorry, my stretch is actually flatter. My stretch is actually flatter and my shrink is steeper, because they're opposite, right? If it's a stretch, it was actually less than 1. If it's a shrink, it was greater than 1. Are y'all okay there? Y-intercept here still stays the same. Are we alright with that? So if your y-intercept also moves, then there was more than one transformation. Is everybody alright with that? Okay. Here, I have f of x minus c. Is that vertical or horizontal? Horizontal. And remember, I'm going to set that equal to 0 to find what c is. Technically, you don't really have to do that. But. Alright, so that's going to be an ht either to the right or to the left. Are we okay there? If I move to the right, it would have been minus c. If I moved to the left, it would have been a plus c. Are we alright? Alright. It's going to move my x-intercept. Now, as a side effect, the y-intercept is also going to move. Are we okay? But it's an x movement. So we're counting left and right. What about slope here? Stays the same. Are we alright? Alright, the last one. If I have f of x plus d, it's on the outside, so it is vertical. That would be vt up or down. Up means I added, down would mean I subtracted. That is going to move my y-intercept. The slope is going to stay the same. Everybody okay there? Alright, we're on one more thing down here at the bottom. If you have a negative out front of f of x, on the outside out here, that is going to be an x-axis reflect. Those are the only one they really showed you, but you also have to know the y-axis. It would look like f of the negative would be inside with X. Are we okay there? That one would be the y-axis. You don't see it very often, but it does happen. So I do want you to understand, if the negative's on the inside, visually it's still gonna reflect and that's gonna be the same, but you're supposed to know which axis. Is everybody okay?
Yes, ma'am.